Welcome to Mathematical Structure for Computer Science. This is CS 113 course at Pace University, also known as Discrete Mathematics. In these lectures, we're going to cover the tree traversal. The whole concept of tree traversal is how we visit each vertex or each node in a tree. So we have three different ways we can do that. First, by pre-order, in-order, or post-order. So our objective is to go through the traversal algorithms, which is the pre-order, in-order, and post-order. Then also we're going to discuss about the concept of infix, prefix, postfix notation, how we can represent these three types of notation using trees also. So first we start with the tree traversal definition. And as we said, the traversal means how we can visit each vertex or node in a tree. So the procedure for systematically visiting every vertex of an ordered tree are called traversals. So the three most commonly used traversals are pre-order, traversal, in-order traversal, and post-order traversal. Also, we have one method called the level order traversal. So these topics, again, is covered in data structures course, and we have a fourth one, which in this course, we are not going to discuss it. So first, let's go through the pre-order traversal. So pre-order, first I will start with how the name came about. The pre-order traversal means we need to visit the root first. So that's why we say pre-order. When we visit the root first, the next will be the left subtree, then the right subtree. Then the post order, that's why it's called post, we visit the root last. So we go to the left tree, then we go through the right, then we go through the root. Then we also have the in order. In order, that means it's between, the root is in. So we go to left first, then the root, then the right subtree. Always we go through the left subtree first before the right. The difference now is the root. Pre-order means go root first, left and right. In order means go left first, the root and right. Post order means go left and right, then the root. So let's go through the definition of the pre-order traversal. Here we say let P be an ordered, rooted tree with root R. So we have an ordered rooted tree means the tree have a designated root, and also the vertices or the values, they are in order, or whatever the data is, they are in order. So now we are saying that if we have the T, which is our tree, and it consists of only a root, which means you have only one vertex, then we just visit the root and we finish. So if T consists of only of R, which is the root node or vertex, then R is the pre-order traversal of the T. So otherwise, if we have a lot of vertices, then we need to visit the root first, then we go to the left, then we go to the right. So otherwise, suppose that we have T1, T2 up to Tn are the subtrees of R from left to right in T. Then the pre-order traversal begins by visiting the R first, which is the root of the tree, and you continue by traversing T1 in pre-order. Remember, T1 will be on the left, then T2 in pre-order, and so on to Tn. So from the diagram here, we can see that our R, the root tree, we visit that first. Then we go to the left. So our left is T1. T1 so will be a subtree with a root with branches or leaves and node. So if there's another edge with a node or vertex, then we go through that left. So we go we start from the lowest left, and we work it up. Again, we're going to see an example soon. So in the pre-order transversal, again, the first node we visit is the root. That's why we said pre. Then we go through the left subtree. When we finish, we go to the right. Now, when we look at this diagram, it means we go through the R first. Then we go through our leftmost, which is T1. When we finish, we go through T2 all the way to Tn. So the last will be the right. So this is an example. Also, we have the algorithm here. By looking at the algorithm, we can see that they use a recursive. So recursive algorithm will be, if I have only one root or one vertex in the tree, which is the root, then I'm going to return it. Now, if not, then we go through the subtree with C as the root. Remember, for each child, C of R from left to right. So here we say R is our root. C will be my left child. So we go through the subtree, the C left subtree root, which is the C. Then we go through the list. So here we have pre-order, which is recursive concept, calling the function. And we do the pre-order of the T at C. C is the subtree with C as the root of the left subtree. So a very good example is given here. So here we have a tree here. We can see we have the root is A, B, C, D, etc. up to the end. And we want to use the pre-order. So pre-order means we need to visit the root first. Then we go through left, which start from J. Then we move up. So here, first I'll go through the root. So that's why we have A here. Then I'll find the left subtree from the root, which will be B. So B, E, F, this will be our subtree, which is right here. Then we're going from left to right. So the next of the root child will be the C. C have only one vertex. So we write the one vertex then. If C have more than one vertex, then it will be a subtree with more than one vertex. Then the last will be the D. So the D is the right side, the right child of the root. So the right subtree with D as the root. So how do we visit? We start with the, excuse me, we start with the A first. Then we'll go through B. Then we'll go through E. Then we will go through J. So you can see we finish with the left. Then we come to K, because they are in the same level. Then after K, we'll go through N, O, and P. Then we go to the right of B, which is F. Then we go through C. After C, we have the right root is D. So we go through D. D to the left is G and L. So we have to go through G and L. Then we go through M. Then we go through H. Then we go through I. So that's again the whole concept of pre-order. We start with the root first, A. Then I'll go to the leftmost B, leftmost E, Stay left J. I don't have any left no more, so I'll stop at J. Then I will go to the level, which is K. The same, if there's any node with J in the same level, in this case is K. So from J, I'll go to K. But I can see that I have some vertices down. So I can't go up. I have to finish down. So from K, I'll go through N, O, and P. Then I'll go through F. And that will be the conclusion of the left subtree with B as the root. So I'll go to the next. Our next will be C. The root A, I have a child C. And C is only one. So after F, we have C. Then we move to the right subtree with the root as D. Then when we are the root D, we'll go through the left first before right. So we go through D, G, then L. L and M are in the same level. So from L, we go through M. Then we go through H. Then we have I. H and I. So that's the pre-order transversal. Now, in order transversal, as we said, first we will go through the left, then we come to the root, then we'll go through the right subtree. So the definition said, let T be an ordered rooted tree with root R. If T consists of only of R, we have only one vertex. Then we are going to return R as our in-order transversal of the tree T. Otherwise, suppose that we have subtree of T1, T2, all the way to Tn, then we need to visit from left to right in T. So the in-order transversal always begins by transversing T1 first, which is the left. Then when we finish with the left, we visit the R, the root. Then we continue transversing T2 all the way to Tn. So to go T1, R, T2, all the way to Tn. So let's see the example again. Also, we have the algorithm for in order. So in order means we are using recursion also. So our base case will be, if we have a tree with only one node, which is the root, then we are going to visit the root. We return R is a leaf, then leaves R. Otherwise, we need to go to the left first child of the R from left to right. So we have the subtree with L, the left side, the root, subtree with L as its root. So the in order of T, the subtree of T with L as the root. So if we go through the L, which is the left subtree finish, then we go through the R, the root. And after that, we continue until we finish through the right. So this is a very good example. Again, the same tree. This time we are doing in order. Remember, pre-order means go through the left first. The root. Go through the root A first. Then we have B. We finish all the left. Then we continue level. Now, in order means we go through the left first, not the root first. Pre-order means root first. So in this case, I will come to the lowest left. This is where I'm going to start. Instead of pre-order, we start from A, then we go through B, E, J, then K, then M, N, O, P, then F, then C, then D, then G, L, M, H, I. That's pre-order. A, root to the left, B, E, J, the same level with K, then M, N, N, O, P. We finish with the left, then we come to F, then we come to C, then we come to D, then G, L, M, H, M, G, M, H, I. excuse me, then we finish. Now with the in order is different. We start with J, then we go up. So J, E, then N, then K, then O, then P, then we go through B. Then after we reach B, we haven't finished, B have a child here. So we go B, then we go F. So we make sure that we finish the whole left subtree. At the moment we finish all the left subtree. So we start with the J, E, then N, then K, then O, then P, then B, then F. Since we finish with all the left subtree, then we go through the root now. So the root is A. Then we continue till we reach it. So the next will be C. The next will be, we go through the right subtree, but this is not pre-order. So we have to start from the left, the lowest left, as we start with the J, lowest left of the subtree of B root to the left. So we go through L, then G, then M, which means we finish the subtree of G. Then we go through H, then I. So we can see the result here. So we go through J, E, again J, E, N, K, O, P. Then we go through B and then the F. Then we go through C, leftmost down L. Then the same level with M, so L, M. Then we go through D. Then after D, we go through H and I. So that's our in-order traversal. Now, post-order traversal means we will go through the left first, then the right, our root is last. So let T again be an ordered rooted tree with root R. If T consists of only R, then we return the R as the post-order traversal of T. Otherwise, suppose that we have T1, T2, all the way to Tn at the subtrees of R. R is the root from left to right. Then we go through from T1 all the way to Tn, from left to the right. Then after we finish, the last will be the root. So begin by transversing T1 in post order, then T2 in post order, and so on. Then after we finish Tn, which means we finish left to right, then we transverse in post order to R. So we are using the same tree again. So this is an example. So first we identify the left subtree, which the rooted is B. The right subtree of the root A is the rooted tree will be D, and the rest. And C is by itself again. And the root itself is A. So post means go through the left. We need to go through all this, the left subtree. The next will be the C. The last will be the right. Then after we finish, we go through the A. So this means I'll start from J, N, O, P, K, E, F, and B. Then the next will be C. After that, I'll go through L, M, G, H, I, then D. So I finish with the left and right subtrees. Then the last will be A. So let's look. So that's the best way to do this is to break the rooted tree of the subtree to the left and the right, and then the root. So looking at this, we know where we need to start. So we start with the J, the same level. J have the same level of K, but K have children. So which means we go from J, we have to go through the children, N, O, P before we come to K. Then we go through E. E also is in the same level with F. So we go through F, then B last. Then the next will be C. Then we go down to L. Then after L, we have the same level with M. So L, M, then we go through G. G have the same level with H and I. So we go through H and I. Then we go through D. Then we go through the root last, which is A. So we also have what we call the expression trees. Sometimes we may have a compressed expressions, which we can represent it using the ordered rooted trees. So consider the following expression: x plus y square plus x minus 4 divided by 3. We can represent this in expression trees. So first we have x and y. So we can, when we are building this, it's good to start from the leaf. So based on the expression here, we know that x plus y will execute first because it's in parentheses. So we have x and y. The operator is always the root. So this will represent x plus y. Then next, we need to square it. So the answer we get plus x plus y. We have another root square with 2. So x plus y square and a 2. So after we square 2, the next we are going to do x minus 4. So we have x minus 4 here. Operator is the root and the operands are s and 4. Then we divide by 3. So we're going to have operator division up and to the right, divide by 3. Then now we need to add both. So we use a plus, and then we combine these two together, the answers. So we have plus, we had the left side and the right side. Left side is x plus y all squared. Right side is x minus 4 divided by 3. So here we can read it. The VCT will be from down up. So x plus y. The answer here, we square it by 2. Then we keep it. We can't go to the root yet. We need 2 expressions here, then we go through. So we keep the answer here. Then we have x minus 4 divided by 3, so division. When we get the answer now, we can add, the root is plus, so we can add the 2 left and right subtree result. And also the infix notation is what we always know. So example here, this is an infix notation. Infix notation means the operator is always between 2 operands. If it's a binary operator like plus, division, 6 divided by 3 is an infix notation. I can write this in prefix notation by writing divide 6 and 3 or 6 and 4. So the operator will come to in front of the values. Post, the operator will be at the back of the 2 values. So 3 plus 4 will be 3, 4 plus for post. For pre, it will be plus 3, 4. Post will be 3, 4 plus. So infix notation means an in-order traversal of a tree representing an expression produces the original expression when parentheses are included, except for unary operations, which now immediately follow their operands. Now we illustrate this, use why parentheses are needed with an example that displays 3 trace all here the same infix representation. So in our previous example, this means x plus y, x plus 3. The answer we get, we divide the 2. So which means x plus y should have parentheses divided by x plus 3. If we don't have no parentheses, it means we are going to get x plus 3 divided by x plus y. So if here we have a parenthesis because x plus y, the first 3, the answer we get is going to divide x plus 3. So division will be last. Now, If I'm doing left to right, then I'll get x plus y. The answer I will get, I'm going to have a division by x. The answer I will get then minus the 3, which is there's no parenthesis. I'm doing left to right. So that's an example here. I will get y divided by x. The answer I will get, I will say plus 4. Then the answer I will get, I will say plus 3. So there's no parenthesis here. Also, the same thing apply here, no parenthesis, x plus 3. The answer I'll get here, I'll divide by y. The answer I'll get here, I'll add it to 3. So we can see the difference of the three structures just because of the parentheses. Because parentheses will change the order of operations. Everything in parentheses must be operated first before multiplication, division, and then addition, subtraction outside the parentheses. So a prefix means we write the operators in front of the values or the operands. So example here, I have x plus y squared plus x minus 4 divided by 3. This is infix. Now to write the prefix of this, first I'll look at x plus y. So I'm going to write plus sy. So we have plus sy. The next operator will be divided by 2. Oh, sorry, to the power 2. So I'll write the 2 after y, then I'll put the operator in the front. Then we have parentheses, so we can't do addition yet. We do s minus 4, so you can see that we have s4 and then the minus. Then we have divided by 3. Then the answer I'll get in both, I'm going to add it, so I'll put the plus in front. So this is the prefix. And how do I read this prefix? I can see here that, okay, I'll start with s plus 2. The answer I'll get, I'll divide by 2. I don't have any operands no more, so I can't do the plus. Then I'll go here, s minus 4 divided by 3. I can't go further. So the answer I'll get here, and the previous answer I'll get up to here, I will use the plus operator in the front to add them together. So prefix means the operators comes first before the operands. And this is an example given. So if I have an expression like this, the first thing we can do will be 2 to the power 3, which is 8. Then I see division here, so 8 divided by 4, which is 2. Then when I come here, I can see the operator with 2 values here. We can't use 3 values because these operators are binary operators. So multiplication in front of 2 and 3 will give me 6. Then when I look at this expression, I still have minus in front of 6 and 5. So 6 minus 5 is 1. Now I have plus 1 and 2, so I'll add it 2. Then we also have a postfix notation. Postfix notation means the operators will be at the back, the values will be in the front. Prefix, as we said, the operators are rather in the front and the values are in the back. So with the same expression here, we can write in the, again, in the postfix notation. So when I look here, I have s plus y. So instead of saying plus sy, I will say sy plus. And that's what we have here. Next, we have to the power 2. So which means I'm going to write the 2 first and then the power. Then next, we have s minus 4. So I have s4 and then the minus. Then divided by 3. So I have 3, then the division. And later I have to add the 2 values, so I put the plus in the front. Now let's go through this example. Here they say we should show the steps used to evaluate a particular postfix expression. So when we see this value, look at the 2 values before the operator. So first I look at the multiplication, which means the first two values will be 2, 3. So 2 times 3 is 6. And this is what we have now. Next, I can look at the operator again. So it means 7 minus 6. So again, we have 2 times 3 is 6. Next, we have 7 minus 6, which gives us 1. So we have 1 here. Now we have one operator here. So this operator means we are going to say 1 to the power 4, which is still 1. Now I have 1, 2, 1, 9, 3, then I have operator again. So I'm going to use the first 3 values before the operator. This is post. So always the first 2 values. Here, the first 2 values, 1, 4, then the operator. Now 9, 3 division. So it will be 9 divided by 3, which gives us 3. So now we have 1, 3 plus, so which means 1 plus 3, which will give us 4. So that is the postfix. Preface, the operator will come, then the next 2 values. Postfix, 2 values first, then the operator. And you are going to use. Then infix is what we know. Always the values are between the operators. I mean, the values are within, the operator is in the middle of 2 values. So let's go through some problems here. Here they say, in which order are the vertices of the order rooted tree in exercise 9 visited using an in-order transversal? So if I want to use an in-order transversal, how am I going to visit all these vertices? In what order? In order means what? You go through the left subtree first of the root, then we go to the next, the right, the root. In order means left first, then you go through the root, then after that you go through the next, the right. So which means we have to go through the left subtree of the root A is from B here. After we finish, we'll visit the root, then we visit C, then we'll visit the right. So the answer here will be, as we can see it here, we have to go through the leftmost and go through all the levels. So we go through K, E, L, and M. So K, E, L, and M. Now, if I finish, I'll go through B. Then B, I have F. Then after F, we start with the leftmost, lowest, so it's R. Then R, we go through N and S. Then we go through G. We already went through B, so now next we go through the root, which is A. The next left will be C. After C, we go through the leftmost of the right subtree with the root D. So that will be O, then H, then we go through D, then I, then P, then J, then the Q. So again, in order means go through the left first, then the root, and then the right. So we start with K, E, L, M. Then we go through B, F, R, N, S, G, A, and C. Then O, H, D, I. Then the leftmost will be P, then J, then Q. So question number 2 says we should draw the ordered root tree corresponding to each of the arithmetic expression written in prefix notation. Then we should write each expression using the infix notation. So I have plus, multiplication plus minus 53214. So I'm going to start with the first two values. So I'll use the minus. So here we have the minus as a root, then 53. So when I finish with this, I will get one value. I will use that value with 2 to get plus. So that's why we leave the minus. The answer we get here, plus 2. So plus will be the root, and the next value will be 2. Now I'm going to have answer here, and that answer, I'm going to use multiplication and 1 with it. So we have multiplication and 1. The answer I will get, I'll use it with plus and 4. So I have plus and 4. So here we start with the first operator, which is close or next to the value. That will be the first operator. So minus, the next two values will be 5 minus 3. The answer you get, the next operator is plus, so it will be plus 2. So that's why we have plus 2 here. Then the answer we get, next operator is multiplication. So multiply everything by 1. Now the answer you get, you add it to 4, and that's the last. So we have 5 minus 3. The answer is plus 2. The answer we get, we multiply by 1. The answer we get, we add it to 4. Now to write this expression in Infix, we can see that it's very straightforward. 5 minus 3, because it's minus. Remember the answer we get, we add it to 2. So you put parentheses plus 2. So plus 2. Then the answer we get, we multiply by 1. Then the answer we get, we add it to 4. But the reason why we have a parenthesis, because plus 4 will be the last operator to execute. So 5 minus 3, we put in parentheses, plus 2, we put them in parentheses, because we are going to do that, then multiply by 1, then we put it in parentheses. Then the answer we get, we add it to 4, and we put it in parentheses. The parentheses here is very important, otherwise the order of operation in this graph will change. But I want to do minus first, plus second, multiplication, then the last plus again. Now in B, we have to look at the question. So I will have a plus 2, 3 here. Then after plus 2, 3, the next operator, I don't have any value to the next value to 2, 3. So which means I'm going to have a new root by itself in the same level with 2, 3. So I have 5 minus 1. Now the answer with plus 2, 3 and 5 minus 1, we square everything. So our operator is square. The answer we get, we square it. Now to write the infix of this, I'll say 2 plus 3 in parentheses, then 5 minus 3 in parentheses. Then we square between, because it's left to right and then the square. Now for C, we have 9, 3, so we start with the 9, 3 division. After that, we don't have any value, so we go through 2, 4. After 2 times 4, we have 7 minus 6. After that, the next operator is plus, so we had the 2. 2 times 4 plus 7 minus 6, so we have the plus. Then the answer we get, we multiply. The last is multiplication. Now, if I want to write this in Infix, we get 9 divided by 3 times 2 multiplied by 4 in parentheses. Then the next will be 7 minus 6, and the 2 is plus, so plus 7 minus 6. So this will be the conclusion of our lectures in a tree transversal. So transversal of a tree again means how we visit each vertex in a tree. So we have three methods, as we said. And the first one is the in order, which means we go through the left subtree of the root, then we go through the root, then we go through the right subtree of the root. That will be, again, in order. Pre-order means we go through the root first, then the left subtree, then the right subtree. Post-order means we go through the left subtree, right subtree, then the root last. And also we saw some 2 examples, and we have some few homework questions too. So again, if you have a question, you can send an email, or you can reach me on my contact number. Again, wish everybody the best. Thank you.